I knew I'd needed it a little bit earlier, I would have warned you, but it is what it is. So, the first section we're going to do, and hopefully quite quickly, is 7.6 using tables. It's still going to be in your homework. It will not be in the next test, nor will it be in the final. Really, using tables is a kind of thing that you would do from time to time when you get an integral that is either impossible for you to do because there's none of the techniques that you know of at this point in time, at least, that allows you to solve it, or it's quicker to get an answer from a table than to do, say, an X sub, and spend 25 minutes. So how do you actually use these tables? Well, let me give you the strategy. This is a general strategy, but you won't use it all the time. But look at your integral and choose a u sub if you need. So the u sub might be u equals sine x or u equals e to x. It'll be a relatively straightforward u sub. Now, once you've done that, do the u sub stuff, and then you can choose an entry from the table and then write down that answer. And then if you need to, convert back. In a lot of questions, you'll only need to really do step 2, and the u sub will just be that u equals x. So that's the generic how you do this type of question. So let me put it into practice. I have on Canvas a PDF copy of all the tables, this guy. Now, for instance, if you look at question 63 here, maybe I should make them big. If you look at question 63 here, if you want to find the integral of sine squared u du, it's a half u minus 1/4 the sine of 2u plus c, and that's called entry 63. I don't know why they called it that, but that's what it's called, right? Now, in our case, if you had to find sine squared x, wouldn't you just call it u equals x and you got your answer, right? Now, suppose you wanted to find sine squared in brackets 2x plus 1, right? Then wouldn't you do a u sub of 2x plus 1 and then you could get the answer, right? So sometimes the u sub is just turn the u into an x and is good to go. That would make it step 2. And sometimes you really do have to do a u sub and some work, and then you use the tables. So if I was going to do question 1, here is the integral, and it even tells me which entry. So I zoom over here and I try and find entry 113. Looks like I may have got some of my guys out of sync, but that's fine. Now, can you look at 113 and you look at this guy? Now, if you replace the x with the u, it looks just like this guy, but with one added little difficulty. Do you see how this says 2a? Now, what number will 2a be in this question here?
1.
Well, if a was, 2a would be 1, correct. So a would be a half. Does that make sense? 2a would be equal to 1. I think I may have to write this down because it is quite verbal. So all I'm doing right now is writing down the question, and right beside it, I'm writing down entry 113, and I can perhaps show you what I'm getting at. Right. Okay, this is the guy we're going to get the integral of. This is entry 113. How can I use this guy to figure out who he is? Well, if I just turn the guys into u's, which is basically a u sub, right? But it's easier to just think of it as a replacement. This guy doesn't quite look like this guy. Would you agree? He's very close to being this guy, but he's not this guy. What value does a have to equal to make this become that? So that's when I asked you what's the A equal to, and someone said, look, 2A should be 1. Can you see that A is a half? Now, when you look at the entry for 113, it also tells you what it is equal to. And it's equal to U take away A over 2, the square root of 2AU minus U squared, and some stuff I can't see because it's off the side of my screen, right? Well, don't you just say U take away a half over 2, square root of, well, 2A gets, well, let's turn it into x's. Then you've got 2ax, which gets you an x minus an x squared, and off you go. I mean, the key was just to realise that A is a half and call all the u's x's. So make A equals a half, call all the u's x's, and you're done. Now, I've actually looked, and quite a lot of you have already done this, which is good, because it means that I hopefully don't need to spend too much doing these. So let's look at question 2. X squared, the square root of 25 minus x squared. So we have to go hunting in this list of integrals for a guy that has that shape to it. Now, at the top of a bunch, they have an idea of the family that they're talking about. So this bunch of integrals all involve a square root. If I scroll down a little bit further, is it further or up? If I scroll up,
We can't see the screen.
Thank you. Let's go back there. Right, suppose I was trying to do question 2, then I have to go hunting. I hope I put the whole thing in. It looks like I may have missed one. Okay, here we go. So I'm looking for a x squared square root. Right, now that guy looks very close, right? You see the only difference is it has a u. And there's one. Can you see that guy there? Now, is that quite the right one? You had a plus there. I think I might want a minus because it's 25 minus x squared. And I think I am in the right one. On the screen on the right-hand side, one of those integrals from 30 to 37 matches the shape of this one. Which number?
31.
Say again?
31.
31. Would you agree? Now, in question 31, don't you call the u an x? So that's the easy bit. What number will you use for A when you go over here to get the rest of the answer?
5.
5.
Right. So every A becomes a 5 and every U becomes an X, and you're finished. So it's just a matter of translation, right? Every U is an X, every A is a number 5. So that would be X over 8, 2x squared, take away 25, square root of 25, take away x squared, plus, God, whatever 5 to the power of 4 is, 625, 8, inverse sine of x over 5 plus c. Do you see that once you know A and you realize that x and u are interchangeable, isn't just a matter of plug and chug, right? Just plug in a number, you got your formula. What u sub should I use in question 3 in order to get the table? So I do need a u sub in question 3.
Sine?
Yes, just sine. And if you do it, can you trust me? You get 1 over u squared take away 64. You just trust me on that, right? That's what you'll get. Then don't you go looking for a table that tells you how to get the integral of 1 over u squared take away 64, right? It'll probably be called 1 over u squared take away a squared. And if I go hunting for it, I might be able to find one. And there we go. It'd be number 20 that I would use. I'm going to write down the gist of what I just said, because you're not all verbal learners. Here it goes. So imagine that you're trying to do question 3. Now the U sub that you would use would be sine x, and you're just going to trust me, you go through the whole thing, and it ends up being that guy. You just say 5 minutes later, you get that. Now that guy is entry 20. Entry 20 looks like this. And entry 20 then says, if you want the answer, you need to know the A is what number?
8.
8. Right? So A is 8 using entry 20. Now entry 20 says that the answer is 1 over 2A, the natural log of U minus A over U plus A with a C. Now since A is 8, it's 1/16, the natural log of this guy over that guy. And now you've got the answer. So there's a U sub that turns it into one of these. That becomes an entry. You get the answer. And then you have to do one more thing or it's not finished. What was step 3? Convert back into the x's or the thetas or whatever it happened to be. In this case, it was sine x. That makes sense. So that's the process. Now, we're going to return back to the original questions. There are only 10 of them. And we'll talk a little bit more about how you solve them. Question 4 does not need a U sub. All you need to do is go look for something that looks like number 4, right? The X is replaced by U's. So you're going to look for something that has 25 U squared plus 4 over U squared, right? And there's going to be an integral in there that has that shape. In question 5, it is a straightforward finding. Well, don't even bother finding an entry. They told you who it is, right? So you know where to look. In this case, the X will be a U. And so what do you do about this weird 7? Well, I would suggest you stick it outside, right? And then just look for that guy, right? The square root of 4U squared minus 3. It'll probably be called AU squared plus B or something, right? But it'll be the same thing. Straightforward table of integrals. Number 7 is a little bit different. You're being asked to find this integral cos 6. So I'm going to find the guy that's got a cos something in it. Okay, where are you hiding?
Cosine
There we go.
squared.
Here we are. Cos to the 6th power is going to be number 74. So let me show you how you use that one. I won't do the integral from 0 to pi part. That you can do yourself. Now, the guy that I'm going to use is number 74. Now, entry 74 says the cosine to the nth power of u is 1 over n the cosine of the n take away 1th power of u, sine of u, plus n minus 1 over n, the integral of this guy. God, that's a horrible answer, but it is what we need to use. So let's show you how this one works. This is a one-off, kind of messy answer, really. I'm going to use this to get the answer to that. First bit's easy. Can't I just call theta u? Right, so every u is a theta, right? Now, if that is 6, that means n is 6, right? That's 6. So every n that you see here is 6. And every u that you see will be theta. So what do we get? We get 1 over 6, the cosine to n take away 1, so that's the 5th power of theta. Sine u becomes sine theta. Take away n minus 1 over n is basically 5/6. The integral of the cosine of n take away 2 is 4 theta d theta. Now, do you notice that that's not complete? All that's done is take this guy and reduce it. It's sometimes called the reduction formula. What do you think I'm going to do to find out what that guy is?
Find it on the table.
And it's this guy again, isn't it?
Yes.
But now with n equals 4. So I have the original piece, which hasn't changed. It's still there. Yes?
Shouldn't it be plus then 5/6?
Thank you. Then it's plus 5/6. And then I'll put a big bracket around the horrible mess. And when you make it 4, you get 1/4 cosine cubed theta sine theta, plus when you make n 4, you get 3/4 the integral of cos squared theta d theta. And then I've got 1/6 of this guy. That times that gets me 5/24 of this guy. That times that gets me 15/24 of this guy. Told you it was a really long, ugly question. And now I am left with needing to get that guy. And can I get that guy 2 different ways? Couldn't I just do the fact that I know it's a half 1 plus cosine of 2 theta and do it that way? Or couldn't I just use this formula with n equal 2? So if you imagine n equals 2 being there and blah, 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 off you go and finish it. So that is the ugliest one of the set. Right, it's just downright ugly. So we've got a few more to try, and then I'm going to call this one done. Are we good with this process, as messy as it is? It's more messy than hard. Right, now, the last 4 questions, whatever it is. Three questions. Question 8. You need a U sub. Give me a U sub, and it's a weird one that would work for question 8.
Square root of x?
It does. Do you know when you do a square root of x, you just trust me on this, you get a half inverse tan of u. And that you can look up in the tables. Right, so if you use a U sub of u equals the square root of x, 5 minutes later, you will end up with 1/2 the inverse tan of u du. You can look up the inverse tan of u, right, from the tables and stick a half in front of it. Question 9 needs a U sub.
Sine X.
You nailed it. And if you do sine x, God in Himmel, you're going to end up with 8u squared log u. Right, trust me, 8u squared log u. Do you know you can actually go to the tables and get that guy? But it will be a reduction formula. Me personally, I probably would just do integration by parts because it's quicker. But that's me. Now, question 10, one of these is the right integral. But I need a U sub. And this one will challenge you because it is not a normal U sub either.
3x.
Say that, it sounded right. Say it again.
3x.
Right, e to the power 3x. The whole thing.
Oh,
Right.
yeah, I guess.
Right, e to the power 3x. It works, right? Check it out. There's some weird 3 floating around, but that's fine. You can make it happen. And that is the end of using tables. So sometime in the future, hopefully not too often, you're going to be doing a question where the integral is just not doable as far as your skill set is at this point in time, right? So you end up having to do, you know, the integral of some weird thing, and you just don't know what to do. It may be that that guy is one of the guys from the tables. In fact, I know for sure, didn't we get, oh God, what was it now? Wasn't there a question about 2 weeks ago where you couldn't really do it by the math that we knew? And you just said, look, if you go and look up the tables, I'll tell you what it is. I think it was something like secant x on its own. Pretty sure it was. Right, that was in this tables. So now and again, you're going to do a question, you're going to be asked to integrate something, and it ain't possible. And then that would be a good candidate for looking up the tables. Right. Hopefully, fingers crossed, it doesn't happen much, but it can. So, time for our new guy. So I'm going to cross this guy off. I'm going to cross this guy off. If you would bear with me for a few seconds, I have to set some things up here. We are going to start chapter 8 today. I'm just getting the thing on the screen. It's too big. Perfect. Okay. Well, what is chapter 8? Its main theme is applications of integrals. So you're going to find that we do things like how you can use integrals to find arc length, surface area, hydrostatic pressure, and some other things I can't remember at this moment. So let's show you how it works. How long is a piece of string? If you start on a curve y equals f of x and you travel along the curve, then it has a length, right? You know, if you imagine a little ant walking along it, how far would I travel? We call that the arc length. So how long is a piece of bent string? That's what we're trying to find. How do you find it? Well, here is a lovely little formula that tells you how to do it. The arc length from x equals a to x equals b of the function y equals f of x is the integral from a to b of the square root of 1 plus the derivative squared. And you can go and look at the textbook and they'll prove it to you, right? There's a theorem, a proof that proves that that's what it is. Right? Now, you can also be given an arc length question when the function is written. So like this. You know, like x equals y cubed plus y, you know, that kind of look. And when they're written that way, can you see that the integral formula looks very similar? It's just from the integral from y equals c to y equals d of the square root of 1 plus the derivative squared. But now, again, I made that mistake there. But now, in terms of y. It's not the ugliest formula in the world. Do you agree? You square the derivative, add 1, stick it inside the square root, and try and find out how to integrate it. Now, sometimes the integral will be a guy that looks like this. And if he is, won't you go and look up the tables? Because that's one of those questions you can't really do otherwise. But not all the time. What is going to happen in these questions? Well, there are three main things that can happen. The first one is that you get the square root of a number. The second type, you get the square root of a perfect square. And the third time, you get an integral that looks like a u-sub, and it is. And I guess the fourth time, which I'm putting little dots around, because you will only use number 4 as the last resort. You will always try and do it exactly using math, not, oh, I'll just look up a table. Looking up the tables is close to, it's not the same thing as, but isn't it close to just looking at the back of the book and writing down what the answer is? Right. And so we don't really want to do that. Now, if it ends up being a number, right? Suppose it's the integral from 0 to 1, right? Well, if it's a number, even a weird number, don't you just add x to it? And you get your answer. If it's a perfect square, well, won't we use the fact that the square root of a perfect square cancel each other out? And then we can get the answer. And when it's a guy that looks like this, won't we do a u-sub and get the answer that way? So I'm being kind of very generic here, right? We're not really doing any specific question. I'm just saying, when you do these questions, these are the types of things that will happen. Now, unfortunately, you might end up with a weird integral that really isn't doable. Okay, then that is, I'll go and look up the tables, right? And I'll find the guy that he's the same as and get the answer that way, right? But try and avoid that. There is a backup to 4. You use your calculator. And I hope that you know how to use your calculator to get integrals. And if you don't, when we come across that question, I'll show you then. But I would probably count that as number 4, right? 4 is, I don't know how to get the integral, I'll use the tables, or I don't know how to get the integral, so I'll just get a decimal answer on my calculator. None of these 3 will be decimal answers. They will be square root of 17 over 4 or whatever, right? They have to be exact values. Any questions so far?
Could you explain number 2? I'm a little bit confused.
This one?
Yeah.
Yeah. If you take the square root of a perfect square, don't the square and the square root cancel out and you're just left with, that's a 4. You're just left with this guy.
Okay.
So that's all I'm doing. So if you get a perfect square, that's nice. The main problem with these questions is, isn't integrals with square roots really hard to do? They just are, right? Questions that have square roots in them are just difficult to do. So here's my first example. Let's suppose we have a function f of x, and it's equal to the straight line 3x plus 1. And I want to know the arc length from x equals 1 to 2. You can imagine what that would be. It would be a straight line starting at 0, right, and finishing up here at 2. And you're trying to find, that distance there, right? That's what we call it. Well, according to the formula, it's the integral from 0 to 2, the square root of 1 plus, well, the derivative of 3x plus 1 is just 3, so you get that, dx. So you get the integral from 0 to 2, the square root of 10. So this would count as situation 1, agreed? Square root of a number. Now, it'd be nice if it'd been the square root of 25, because then I could have said 5. But it's still a number, right? That's all it is. Integrate antiderivative of number. You get the same number with an x, evaluated from x equals 0 to x equals 2. That's square root of 10 times 2, take away nothing, and the answer is 2 root 10. A little bit quick, but does that process of how to find an arc length for a very primitive function seem pretty much use the formula, call it good. So after giving you a nice warm-up one, let's make your life a misery by doing example 2. And I'm going to show you almost the exact opposite of easy, right? Really ugly coming up. This one is in fact similar to question 1 in the homework, and it's y equals the square root of 2 take away x squared and doing that, right?
I can't see it.
Oh,
Yeah, that's good.
it's weird. Is it disappearing on this side? Can I?
Yeah, I just couldn't do the 1, but that's good.
Okay, right. I guess what I better do right now is, don't I need to find the derivative? Ooh, I should have thought a little bit more closely about that. Won't I have to call it this guy in order to differentiate it, right? Do you recognize this as a Calc 1 problem called a chain rule? Right? It's something to the power of half. The derivative is 1/2, reduce the power by 1, which is negative 1/2, times the derivative of 2 minus x squared. And what is the derivative of 2 minus x
2x.
squared? With a negative in front of it. Now we're going to do style points. Style points are make it, as pretty as you can and make it look like the original. So this times this gets me negative x. This negative 1/2 power becomes that. And this now becomes that. So far, so good. The derivative is this guy. Any of that you're not sure about, can we continue? Now, according to my formula, won't I square the derivative and add 1? So let's do that. 1 plus the derivative squared. 1 plus this guy squared. What should I do next?
U sub?
Not yet. Too early to think about U subs, Matthew. What should I do algebraically next? I want it to look better than it is, because that looks yuck.
Multiply it together.
Right. So this guy squared basically means this guy times itself. So the two top guys are negative x times another negative x, positive x squared. And the good news is, isn't the square root of 2 minus x squared times another 2 minus x squared, just 2 minus x squared. So good news is, the square roots have gone. Right? Now, no, it's not a U sub. What do I do now algebraically to make it even nicer? So we are using some skill sets from algebra. I don't know when you did these last, but probably a good chunk of time ago.
Isn't
You
this?
You multiply the 1 by 2 minus x squared.
It's a
Isn't
bit
this
like
all
that.
under a square root? Sorry.
Oh yeah, it will be, but
Okay.
I just don't want to have to write 20 square roots. So yeah, you're right. But once it is done, then I'll go over here and this integral will be ready to go. But you are right. Are you happy about the one turning into this, guys? A bit like partial fractions, you know, give me what I don't have. Now, when you combine these, you are left with 2 over 2 minus x squared. So far, so good. Now, can you bring this guy in? It's going to be the integral from 0 to 1, the square root of 2 over 2 minus x squared dx. Algebraically, so don't even think of U subs, they're not going to be any good to you. Algebraically, what do we do next?
Right, it's
Put a
like
s-
to the 1/2.
That guy? I've gave you both extremes here, if you like. There's a couple of guys in the middle we haven't done yet. This fella here can be done 2 ways. No, rephrase that. 3 ways. First one is, I could just go to my calculator and get a decimal answer. Since the question doesn't say, give me the answer to 3 decimal places, I am not allowed to do that. If they don't mention decimal places, you can't do your calculator. On the other hand, if the question says, give me the answer to 2 decimal places, or use your calculator to get the answer, then I will plug it in and I will get the answer. So that method's out, although I'm going to return to it in a few moments. I could say, I recognize this as an X sub. If I did recognize it, which it is an X sub, does anybody know what X sub it would be?
Be
Sine.
square root of 2
Right.
sine.
Agreed. Now, can you imagine us doing that? And can you trust me, it'll work? What's the going rate for an X sub? At least 10 minutes, right? Or couldn't I go looking for some tables that had a guy that looked something like this fella? And yes, you can. And if you do, you will be using rule number 4. Now, if this is a test question and you go this road, I'm totally happy. And if you screw up, but the method is right, you will get a lot of more points. If you use this method, but you screw up, you won't get anywhere near as many points. So for homework, I would probably go number 4. But for test question, I would go the long way where you do everything yourself, because if you do everything yourself, can't I see the proper process? If you do the tables wrong, all I'll probably see is the wrong answer, right? Because the tables pretty much do the rest. Great. And if you pick the wrong one from the table, well, that's kind of the question finished right away. Now, I did say that I'd return to this question, so let's do that. I still like to know what the answer to this darn thing is. So in some of you, you've got a much nicer way of doing this than me. My calculator's kind of old. So you may be able to find a better way than this. I'm just going to type in the square root, oops, that's the square root of 2 divided by a square root of 2 take away x squared. So I plug that into my calculator. I then go to the window and I choose the integral from 0 to 1. Was it 1? The integral from, yeah, it is 0 to 1. So far, so good. And then I would just zoom fit. And what you'll see right now is the piece of this string that you want to find the length of, right? Just a normal boring curve. If I then go second calc, you see I have a choice number 7, lower limit 0, upper limit 1. And the answer I get is 1.11. So this integral would be approximately 1.111 to 3 decimal places.
Professor,
Yes.
so with this formula, we're like calculating the length of the curve, basically?
Yes. But that's the area under a curve. Is that what you're thinking?
Yeah.
Yeah. The visualization is not what's going on here. That's just the visualization of what this integral is. But this integral, the number that you get is actually the length of the curve. And the length of the curve happens to be the same number as the area under this curve.
Okay.
So you just kind of have to say, okay, how can a length become an area? Well, it can if the area under the curve is the same number as the length. And it's the fact that the numbers are the same, not that the picture is the same.
Okay, thank you.
Are we good? Right, what have we got time? We've got time for, yeah, we got time to start my third example. Which is actually like number 2 from the homework. And x is equal to the square root of y, take away 9y, and y is going to go from 1 to 4, which is fine. If you prefer to call this guy g of y, it might make this formula a little bit clearer. Otherwise, you know, x as a function of y might distract you a little bit. Okay, if I'm going to differentiate this guy, is there anybody I have to rewrite in order to do that?
Square root.
Yeah, and so we're going to call that a half power. Now, if you differentiate, you get that guy. Differentiate this guy, you get -9. Great. There's a kind of way that I tackle these questions, and that is I find out what 1 plus the derivative squared is, and I make it as nice as I can. And then when I'm finished, I stick it in there. So that's kind of the goal. Now, if you take this derivative, and you square it, and I'm taking this kind of slowly because there's some weird stuff going on. If you're wondering why I didn't call that 1 over 2 square root of y, I could have. It wouldn't matter. Okay, what happens if you go this half guy times this half guy, you get 1/4. What power of y do you get when you multiply these two together?
-1.
Correct. So that guy times that guy to the power of -1. Now this guy times this guy, -9/2. This guy times this guy, -9/2. And this guy times this guy is 81. And we now have 1/4 y to -1, take away 9 y to the -1/2 plus 81. Okay. So far, so good. And let's add 1 to it. Well, if you add 1 to this, you will get this fella, add 82. Now, what will that look like as an arc length? It will be the integral from y equals 1 to 4 of the square root of this ugly mess, dy. So 1/4 y to -1 minus this fella. Now, normally I would have done style points to this question, but I'm not going to. By that, I mean I would write this guy as 1/4y, and this guy is -9 over the square root of y, which I certainly could do, plus 82. But I'm not going to, because in question 2, they say, use a calculator. And if you're going to use a calculator, then you don't really need to be too fussy about style points, because you're never needing to make it look pretty, because the calculator will take it no matter how ugly it is. Now, I know everything here is in y's, but can you pretend they're x's? Because calculators don't care what the variable's called. So it's going to be the square root of 1/4. I'm just going to call that 0.25 because it's quicker. X to the power of x to the power of -1. Subtract 9y, that will become an x, to the power of -1/2, brackets, -1/2, plus 82. Do a window from 1 to 4. Zoom 0. A bit of luck, it will show something. This is basically what that guy looks like. And so if I find the area under that, this will tell me the integral, and this integral is the length of the arc. So you then go second calc, you say choice number 6, start at y equals 1, finish at y equals 4, and the answer will eventually fill in. I've broke the thing.
I think you took the derivative instead of the integral.
Oh, that could have happened. Let's try that again. Second calc, number 7. Start at 1 and finish at 4. There we go. It just gives you a little animation what's going on. So the answer would be 26.17 to 2 decimal places. So can you see when they ask you to do the calculator part, you still have to do this ugly mess and then put it inside the square root. But after that, calculator will do the job, right? Any questions about that? Right.
I'm doing what you're doing, but my calculator doesn't like show the curve like that.
Okay, let's hit Y. Does that look like your square root?
Mm-hmm.
Exactly like that. In particular, you got to make sure you hit a negative or a subtraction in the right place. So that guy is next to the 1, right? This one here. He is a negative. That's down at the bottom under the 3. This guy is subtract. He's the grey negative, right? He's that guy there. That's the most common mistake. Now look at the size. Do you see how it's long when it's a subtract and it's a little bit smaller when it's a negative? So there should be a negative next to the 1 and then later on another negative next to that one. Are both those correct?
Mm-hmm.
Yeah, absolutely sure.
Yeah.
Okay. Then the only other place I guess you could have wrong, did you do zoom 0?
I don't. Is that just like the Z-box thing, or?
No, I do zoom 0. It's called zoom to fit. You should be looking at a curve that looks like that guy. Does it look like that guy in shape?
Well, I click Z-box and
Don't do Z-box. Do zoom 0.
Which one is that one?
It's hit the zoom button and 0.
Oh. Here. Oh, okay. That's what I was doing wrong.
Okay, we fixed it. Now this would have been so much easier if we were in class. Can I just look at your thing and hit some buttons? It's quite frustrating at times when I'm not sure what the problem is because I can't see what you typed or what you're typing very easily. Okay, we cool with this today, guys? Right. If you have any problems with the table stuff, you know, the usual, maybe catch me early tomorrow and we can go over that. And in case I've forgotten, will you all say hi to get your attendance? And that is us, apart from one person who is going to hang about for a little minute at the end so we can talk.
Do you know when the test will be up?
I put the grades up already. I believe I sent out an email. If you haven't got that email, then I will have to do it again because I thought I did.
And that would still that'd be on web, right?
It will not be WebAssign. It will be to whatever email you used in WebAssign.
Okay.
So if it's your school email, that's where it'll be. But if you used fred@yahoo.com, that's where it's going to be. So whatever you used as your WebAssign is the one. Now, if you don't want the WebAssign one, which I strongly suggest you don't, because sometimes you forget to look at, you know, at that, is send me an email with your exact school email address. Now, you might think that's easy for me, but it's actually quite hard for me to find it because, believe it or not, there might be 4 Nicholas Nelsons at OC. And so I could be sending it to one of the other 3, and I'm not allowed to do that. So if you shoot me an email saying, this is my particular OC address, I will put that on my spreadsheet. So you'll only need to look there from now on.
Professor, I had one more issue with the calculator.
Yes.
So I have the graph, and then when I go to calc and hit the integral, it like doesn't do it.
Does it stare at you?
It just goes back to the graph and says lower limit question mark.
Okay, so here we go. Second calc. It's number 7.
Mm-hmm.
And it says lower limit. So you press N1 and hit enter. And then it says upper limit and you press N4 and you hit enter.
Okay, that was what I was missing.
Okay, we're good.
Thanks.
Right, so bye-bye, guys. I got some